Good afternoon, third graders. Welcome back to checking our DMA for today. We are on week 29, day 4. So if you notice, our first problem has to do with fractions. Now, if we take a look, we are going to see that we have 3 squares here. And each square has been divided or broken up into 4 equal pieces. That is how we get the denominator. The denominator tells us how many parts each whole has been divided or partitioned into. So if you notice that each one of these is going to be 1/4 of the whole. So if I were to think about this is 1/4, 1/4, 1/4, and 1/4. We have 4/4 in this one whole. Okay? Now remember, 4/4 is equal to 1 whole. So that means that if we hadn't partitioned this rectangle or square, it would be 1/1, right? Now, let's take a look at the next square. This 1 whole square has also been partitioned into 4 equal pieces. So that means we have another 4/4 for that whole rectangle. And if we look at the third rectangle, this whole rectangle has also been partitioned into another 4/4. So if we count, remember the numerator tells us how many parts we are counting or are being described. Well, now we can go and count how many of these fourths do we have. Well, in this hole we have 4, and then in the second hole we have another 4, so that's 8, and in this hole we have another 4/4, and if we put the fourths together we have 12/4. Now, if I were going to show this on a number line, and I'm just going to draw that up here to kind of demonstrate for you what we're talking about. We have 3 whole on this number line, and each of the whole have been partitioned into fourths. So this whole has been partitioned into 4 equal pieces. This second whole has also been partitioned into 4 equal pieces. And finally, the third whole has been partitioned into 4 equal pieces. Now, if I go to label these, I have 1/4, 2/4, in simplest form is a half, 3/4, and 4/4. Now, if I continue on adding one more to the numerator, that means this is 5/4, 6/4, 7/4, and at the 2 we have 8/4. And again, if I continue adding on to my numerator, 9/4, 10/4, 11/4, and finally when we get to the 3 whole, we get 12/4. Now, next year, you'll learn that this is called an improper fraction because the numerator has more parts than the denominator. And so this is just to give us some understanding of what is the numerator. It tells us how many parts of this fraction we have. All right, now let's take a look at our word problem for today. It says 5 friends are splitting. Now, when we say the word splitting, we can also think of the word splitting as sharing. So think about what we've been talking about. When we share something, usually we are using what operation? Adding, subtracting, multiplying, or dividing. If you said dividing, you are correct. So let's take a look at the rest of the problem. 5 friends are sharing a package of 30 lemon drops. So we have our total lemon drops, And it says if they divide the candy evenly, how many lemon drops will each friend get? So again, keywords here: divide, candy evenly, splitting, sharing. Those are all clue words that we're going to be dividing these candies by. What are the groups? The 5 friends, right. So I'm going to take a moment to look and model for you in the back here. So we're going to take the 30 candies and we're going to share them equally, which means we're dividing, and we're putting them into groups, and the groups being the friends. Now, what we're looking for is the candies each friend is going to get from. So we're looking for our, that's called the quotient. What's it called? The quotient. So our dividend is the total candies. Our divisor is the groups in this case. And we're looking for the quotient, which is the number of candies each friend is going to get. So if I take and model this using a bar diagram, I can see that I'm going to have 5 friends, and I'm going to share the 30 candies between those friends. So I need to know how many is in each group. Now, if you know your multiplication facts, and that's why we need to make sure that we know them, we can use what we know about multiplication to help us with our division. So 5 groups of what is going to give me 30? Well, knowing your 5s is fairly common in 3rd grade. We could put 6 in each group. Now, to check, I can use repeated addition. So 6 plus 6 is 12, plus 6 is 18, plus 6 is 24, plus 6 is 30. So that checks out using our repeated addition to check. And now I have a division equation to show my work. I've modeled it. Now I can write my response. So we will start the response with each friend will get 6 candies each because if I share the total of 30, oops, and I need to move my, of 30 equally into 5 groups, then we will have 6 in each group. Okay, so now that you've shown me an equation, we've modeled it, we've even related it to our multiplication, and now we've written it into a response to show our thinking. Let's go ahead and take a look at the next problem. Goes with our understanding of multiplication and division. So we have 35. We put those into 5 equal groups. How many are going to be in each group? Well, remember, we know that 5 times this number is going to give us 35. So we're missing, in division, we're missing the quotient. But in our multiplication sentence, we're missing the factor. So this quotient and this factor are showing that multiplication and division are related to each other. So I've taken the time to go down here to the bottom and show multiples of 5. And so how many groups of 5 is it going to take for me to get to 35? Well, I have 1, 2, 3, 4, 5, 6, 7. So 7 groups of 5 is going to give me 35. Now, if I needed to, what I could do is I could draw 5 groups and then share equally into those groups however many objects I need until I reach 35 total objects and share them equally, which means that I should have 7 in each group. Now, same thing for our next division equation. We have 64. We're dividing it into groups of 8. There should be 8 in each group. So again, looking at my multiples of 8, I counted 8 plus 8 is 16, plus 8 more is 24, plus 8 more is 32, plus 8 more is 40, plus 8 is 48, plus 8 is 56, plus 8 is 64. So I have 1, 2, 3, 4, 5, 6, 7, 8. 8 groups of 8 will give me 64, and I can finish my missing factor here. Last one for this set of problems, we have another division equation. I'm going to take 56 objects, share them equally into 7 groups. I want to know how many is in each group, which will help me find this missing factor here. And so if I do that and count by 7s, I have 7 plus 7 is 14, plus another 7 is 21, plus 7 is 28, plus 7 is 35, plus 7 is 42, plus 7 is 49, which is 7 times 7, and 7 times 8 would be 56. So to get to 56, I need 7 groups of 8. So my missing factor here is going to be 8. All right, let's take a look at our last problem, which is in a fraction, and it says I have the square and it's broken up into 8s. So as of right now, to write this as a fraction, I could write it as 1 over 1. But as soon as I start partitioning this square into equal pieces, my denominator is going to change. Because right now, I have not partitioned the square into any pieces. But once I start dividing it, so I'm going to start with half because 8 is a multiple of 2, then my denominator would be half, right? Then, if I go ahead and partition my halves into 2 more pieces, I'm doubling those pieces, and now what happens to my denominator? It becomes fourths. Now, once again, to get 8s, I'm going to double my fourths, which means I'm going to cut them into 2 parts. And now each fourth becomes 8s. So now I've gone from halves to fourths to 8s. Now it asks me to divide the square into 8s and label each eighth with the appropriate fraction. Then shade 2/8 of the square in. So remember, we call these unit fractions. Unit means one of the pieces. What is a unit fraction? One of the parts. So each one of these is going to be 1/8 of this square. Now, it asks me to shade in 2 of the 8s. So my numerator tells me how many parts I'm supposed to shade. So my numerator tells me how many, my denominator tells me how many parts are in the whole. So again, it doesn't matter which ones I shade in, as long as I shade in 2 of them. But I think I will do 2 together. Now, remember, when you have 2 8s, here's your discussion question for today. What is it 2 8s in simplest form? So, for your discussion question today, what is 2 8s in simplest form? And think back to where did we get these? How did we create these 8s? Where did we start dividing? Think about that. Okay? So, discussion question for today, 2 8s in simplest form. See you during our live meeting and have a great afternoon, guys.